Going to talk about the state function in thermodynamics. STAT, state, FUNCTION, function, state function. So any property that does not depend on the path, does not depend on path, does not depend on path, but depends only on states, initial states and final states is called the state function. All right, so let's say what is the state function. Let's say an example here. So this is a gas, we have a gas here. Let's say volume of this gas is V1. Now we can expand this gas different way. So let's expand this gas very fast. This is, let's say, 1 liter, and we expand this gas suddenly to, let's say, 2 liter. So the gas now becomes 2 liter. All right, so there is a gas is 1 liter. Now the gas becomes, when we expand the gas, it becomes 2 liter. So what is the total expansion here? So the volume change is equals to 2 liter minus 1 liter. So this is 1 liter. So we expanded the gas by 1 liter. This is one way of expansion of the gas. All right, so another way also, we can expand this gas another way. Let's say we have this gas at 1 liter mark. Now let's expand this gas in many steps. First, from this 1 liter mark, let's say we expand this gas to 1.2 liter mark. Again, let's expand this gas to 1.3 liter mark. And then let's expand that gas to let's say 2 liter mark. You see that? Now how many steps we take to reach from 1 liter to 2 liter here? 1 step, 2 step, 3 step. In 3 step we expand the gas in 3 step from 1 liter to 2 liter. So what is the total expansion? Total expansion or total volume change equals to the final state is 2 liter, initial state is 1 liter. So 2 minus 1 equals to 1 liter. Either we expand this gas suddenly from 1 liter to 2 liter, or we expand this gas very slowly from 1 liter to 2 liter in many steps. The final value, the volume change, becomes the same. So the volume change only depend on the initial state, this state, and the final state here. So this kind of the property is called the state function. So the volume change is called the state function. All right, so let's take another example. Here. Let's say this is the mountain Everest. Some people start to walk from here and try to go to the top of the mountain like this. All right, so some people walk like this and reach to the mountain. But another people here take the helicopter and directly go to the same mountain top like this. You see that the total displacement or the total altitude traveled by helicopter and the total altitude traveled by these people here is same. So the altitude is either you walk long distance like this, or you take the helicopter and go like this. It's the same thing. All right, so the altitude is also state function. So there are other example of the state function. For example, some people may, let's say this is your college. All right, this is your college. So this is your house here. So this is your house. You may go from house to college by this route, or by this route, or by this route. No matter how you go to the college, from here to here you reach to the college. So the total displacement you cover is same whether you go this way or you go this way or you go this way. It's a path independent. Finally you reach to this place. So this is the displacement. So displacement is a state function, but this distance doesn't count here. All right, thank you very much.